Hello everyone, and welcome. Today, we are going to tackle one of the most common questions in organic chemistry: how to identify the major and minor products of a reaction. This can seem confusing at first, but it almost always boils down to one simple concept: stability. Organic reactions prefer to follow the path of least resistance, which leads to the most stable possible outcome. The product formed from this most stable pathway is the major product, while less stable pathways result in minor products. Let's break down the key ideas you need to know. First, think about reaction intermediates, especially carbocations. A carbocation's stability is critical. A tertiary carbocation, a positive carbon attached to 3 other carbons, is the most stable, followed by secondary, and then primary is the least stable. A reaction will do everything it can to form the most stable carbocation intermediate. This concept is the foundation for our next point, Markovnikov's rule. This rule applies to addition reactions and states that when adding something like HBr to an unsymmetrical alkene, the hydrogen will add to the carbon that already has more hydrogens. The bromine then adds to the other carbon, the one with fewer hydrogens. This happens because this specific pathway creates that more stable tertiary or secondary carbocation, leading directly to the major product. Now, let's consider elimination reactions, where we form double bonds. Here, we often use Zaitsev's rule. This rule predicts that the major product will be the more substituted alkene. More substituted simply means that the carbons of the double bond are attached to more other carbon groups. A more substituted alkene is more stable, so it's the product that the reaction prefers to make. However, there is a very important exception to this rule that involves steric hindrance, or how crowded the molecule is. If you use a large, bulky base like potassium terpetoxide, it has trouble reaching the inner hydrogens needed to form the stable Zaitsev product. It's just too big to squeeze in there. Instead, it will grab a less hindered, more accessible hydrogen from the outside of the molecule. This forms the less substituted alkene, known as the Hofmann product, which becomes the major product in this specific case. So, to find the major product, always ask yourself, which pathway creates the most stable intermediate or the most stable final product? Consider carbocation stability, the degree of substitution on your alkene, and whether any large, bulky reagents are getting in the way. Thank you so much for watching this video. I hope it helped you understand the logic behind major and minor products. If you found this explanation helpful, please hit the like button, share it with your classmates, and be sure to subscribe to the channel for more chemistry tutorials. Your support is greatly appreciated and helps me continue making these videos. Let me know in the comments if you have any questions, and I'll see you next time.